getting. I really want you guys to do well on the assignment, so I'm hoping that these slides will help clarify some things for you. Here's an outline of what we'll go over in this presentation, a quick reminder of the deadline, some answers to common questions that I've been getting, a short overview of how to find your protein for those of you who haven't gotten started yet, and then an overview of the expectations for part 2. This is where I'm getting the most questions, so we'll spend some time going over the expectations for that section, and then we'll go over the expectations for parts 3 and 4 as well. A quick reminder that this assignment is due on Tuesday, October 10th by 5 p.m. Please don't wait until 4:45 p.m. on that day to submit your assignment because Quarkus can get very slow if 1,500 people are all trying to submit at the same time. And if it's even 1 minute after 5 p.m., Quarkus will flag the assignment as late and a late penalty will be applied. And it really pains me to see this, so try and submit the day before if you can. You can submit up to 3 versions, and the newest version will be marked. So if you've already submitted something and you want to go back and make changes, you still can up until the deadline. A reminder to please not copy a previous assignment or another student's assignment. It will be caught by the university's plagiarism detection tool, and it would really pain me to see these penalties applied as well. So please do the assignment independently. And then a reminder to use the library guide. This is a resource, instructions on how to cite your sources in the text and create a list of references at the end of the assignment. This resource shows you how to cite all kinds of sources like web pages, research articles. So it's a great resource, and just a reminder that you do not need to cite lecture notes from BCH 210. Here are the answers to some common questions I've been getting. The first is that you do not need to include a title page in this assignment. There is no word limit for the draft, but there is a 2,000 word limit for the final assignment. So just keep that in mind when you're writing your draft, that you're saving some room at the end for additional discussion that you'll add in the final assignment. Some sections may be longer than others and maybe longer than a page when they have the figures in them, and that's totally fine. What's important is at the end of this that your final assignment is within that 2,000 word limit. A reminder of the PDF naming convention. When you go to submit your assignment, you can find this in the assignment instructions, so please follow this convention. The sources used for your assignment should be peer-reviewed literature, so that includes primary research articles, like the article that has your protein database structure, as well as review articles. And review articles are fantastic sources for an overview of your receptor structure and function. And a great place to start your assignment is looking at review articles if you haven't started yet. And then a quick note about in-text citations. So check out the library guide on the last slide for information on how to cite your sources in the text following the CSE format. All information in a paragraph that comes from one source, you can cite that source at the end of the paragraph rather than after every single sentence. But if there's information from multiple sources in a paragraph, then you would need to cite the sources after the relevant sentences in that paragraph. And this has been discussed on the discussion board for the assignment if you want to look there as well. For those of you who are just getting started, the Protein Data Bank, or PDB, is a database for 3D structures of large biological molecules such as proteins and nucleic acids. PDB numbers are these 4-digit alphanumeric codes, and they correspond to a different protein structure that's been determined using the techniques we've learned about in class, including X-ray crystallography or electron microscopy. And throughout your lectures, you've probably noticed that Dr. Patterson often shows the 4-digit PDB number beside the protein structure on her slides. And if you're ever interested in learning more about these proteins, you can look them up using these 4-digit codes on the PDB website. For this assignment, you choose either the EGF or the VEGF-A growth factors. So read about them online and pick whichever growth factor is most interesting to you. Then you're going to search the literature or online and find out what the receptor is for this growth factor. And then you'll be looking in the protein database for a structure of the receptor, not the growth factor. And I think some students were getting confused about this. For this assignment, you are looking at the structure of the receptor, not the growth factor. You just need to do a little research to find out what the receptor is for your growth factor. Once you've found what the receptor is, then you're going to look for that structure of the receptor on the protein data bank. These receptors are extremely well-studied proteins, so there will be hundreds of structures solved for these receptors, if not more. There might even be thousands. You're unlikely to find a structure of the whole receptor protein because these are very large proteins. Most likely, you'll find structures of specific domains of the receptor protein, and that's okay. You don't need to be looking for the entire protein. You won't find it. Some of these structures may have more than one polypeptide chain, so more than one protein in the structure of the receptor, and that's okay. So the receptor might be dimerized, or it might be in complex with another protein like its growth factor or even other proteins. So there might be more than one polypeptide chain in that structure, and that's fine. Those are great to use too. I think students were getting confused about this, but it's more than fine to use a structure that has more than one polypeptide chain in that complex, because the assignment asks you to discuss the primary, secondary, tertiary, and quaternary structures that you see in your figure of the receptor. So if your receptor is dimerized, or if there are more proteins in your figure than just the receptor, that would be what you can discuss for quaternary structure. So continuing on with how to find your protein receptor, one option is to use this online resource called UniProt, which stands for Universal Protein Resource. This website is a comprehensive resource about protein sequence and protein function information, and you can use this resource to find a protein databank number for your receptor protein, and you would do that by searching for your receptor in the search bar. Just as an example, I've searched for a protein called RET. It's a receptor tyrosine kinase. This is not a protein from your assignment. I've just chosen it as an example. So you would search for your receptor protein and you'd get this table of results from different organisms. And you want to make sure that you're choosing the human isoform of your protein. This website, this UniProt website, has summarized lots of information on proteins, including structure and function, and you can read through everything on the website to learn more about your receptor protein. Then you want to go to the structure page, and you'll see a list of structures for this protein. We want structures that are in the protein data bank. So from source, you would select PDB, and then you'll see a list of structures in a table that are from the protein data bank. And like I mentioned, the receptors for EGF and VEGF-A have been extensively studied, so you'll see hundreds and hundreds of options, maybe even 1,000. Each PDB number corresponds to a different structure from a different paper. And these structures might be of different domains of the receptor protein, maybe of the receptor in its dimerized form, maybe of the receptor in complex with other proteins, such as its growth factor or other proteins, maybe structures of the receptor when it's bound to certain drugs, or receptor with specific mutations. So all kinds of different configurations of the receptor solved using different techniques and using different experimental conditions. So that's why there's so many. And in this table, you can find the 4-digit PDB number corresponding to different structures, the method used to solve that structure, the resolution the structure was solved at, The number of chains in the structure. Chain means polypeptide, so when there's more than one chain in the structure, this means that there's more than one polypeptide or protein in the structure. And chains are differentiated by letters. And then position refers to the amino acids in the full-length protein that are in this chain. So what portion of the protein is in this chain or chains? So here are all the different PDB numbers, and you can pick some numbers and pop them into the Protein Data Bank website to start exploring them and see which structure you want to pick for your assignment. So take any of those PDB numbers, pop them into the search bar on the PDB website, um, and then you can explore that structure. Another option is to skip the UniProt website altogether, and you can just search for the receptor right here on the PDB website. And again, you'll see hundreds of options come up, but just make sure you select a human isoform and not a structure from another species. So then you'll select one of the structures for your receptor on this website, and it will take you to the structure summary page. Again, this is not a protein for your assignment. I've just chosen this protein as an example. On the structure summary page, you'll see an overview of the structure. So what the structure is. In this case, it's extracellular dimeric complex of RET with its growth factor. So it's the structure of RET as a dimer and complex with its growth factor. You'll see the classification of the receptor protein, the organism it's expressed in, whether or not it has mutations or if it's a structure of the wild type protein, and then the method used to solve the structure, and it was electron microscopy. And below all this information is the paper that was published with the structure under the literature heading. These are the researchers who determined the structure using electron microscopy, and they published this paper and then submitted the structure to the Protein Data Bank. And you will need to read and access this paper for your assignment, specifically for part 3. Keep scrolling the structure summary page, and next you'll find the macromolecules section. The macromolecules are proteins and other large molecules. Your receptor would be a macromolecule, and if your growth factor or other proteins are present in the structure, they would also be listed under macromolecules because they are polypeptides. I think some students were getting confused about that. If your growth factor or any other proteins are present in the structure, they would not be under ligands. They would be under macromolecules because they're also polypeptides like the receptor protein. In this example, the receptor structure was bound to its growth factor. So you can see the growth factor listed under macromolecules, and you can also see the number of polypeptide chains for that protein. Polypeptide chains are differentiated by letters. Here we have 2 polypeptide chains, so maybe this growth factor is dimerized. And then sequence length corresponds to the number of amino acids in those chains. Scroll down further and you'd find all this info for any other proteins in the structure, such as the receptor protein, which is what you're interested in for your assignment. So keep scrolling the structure summary tab and you'll come to the small molecules and ligands section. Ligands will be different small molecules that are present at the time the structure was determined. They could be important for protein structure or function. And part 2 of the assignment does require discussion of any ligands present in terms of their interactions with the receptor protein. And I'll provide an example of that at the end of this presentation. So you do need to choose a structure that has some ligands that you can discuss. This protein has some calcium ions, so try and think back to what we learned about calcium ions in lecture 1. And if you see other ligands that you don't recognize, you can do a quick Google search and a little research to see what these are. Then you're going to go to the 3D View tab, which will show you an image of your structure. And the default viewer is this mole viewer. I found this really short, YouTube video made by the Protein Databank website. It's really short, only 10 minutes, and it goes through how to use and navigate this mole viewer window, and that can be really helpful. But basically, you can click anywhere on the structure and it will show you the amino acid name and number that you've clicked on and any of its backbone or side chain interactions, which you'll need to talk about in part 2 of the assignment. If you're using the Protein Databank website to make the figure for your assignment, then you're going to use the NGL viewer, which you select in the bottom right corner. On the Structure View tab, you can play around with the structure and you can change the style, the color, or whether or not ligands are shown. For your assignment, if you're using this PDB website to make your figure, the style needs to be cartoon and the color rainbow. And you can either show the ligands or not in the figure, either way is fine. But whether you show them or not, you still need to discuss them in your assignment, so it's probably better just to show them. So this figure is an option for your assignment and you can zoom in and rotate and get the best angle for your figure, especially because you'll be labeling things. But there are other programs listed at the end of the assignment instructions that can make a bit of a nicer figure. So if you have time, you can play around with those, but this figure is definitely fine to use as well. No matter what website or program you're using to make your figure, here's what must be included in the figure. You must include a figure title and caption. And these, one of them, the figure title or caption must include the PDB number for your structure, as well as the name, which is found directly underneath the PDB number. And you also need to include the source that was used to make the figure, so the PDB website or one of the other programs listed at the end of the assignment instructions. The figure should have a white background. That's to make it easier for the graders when they're looking at your labels. And then using arrows, you need to label the following. You need to label the N and C termini of the receptor. So if there are other proteins present in your structure, you don't need to label their N and C termini. You just need to label the N and C termini of the receptor. If dimerized, you can label the termini on both dimers. If using the PDB website to make your figure, then in the rainbow format, the N terminus will be blue and the C terminus will be red. You will also need to label other proteins or chemicals in the structure if they're present. You don't need to label their N and C termini, but just label the other proteins or chemicals to say what they are. And then also label any ligands if you're showing them in your structure, which is probably a good idea because you're going to be discussing them. Now we'll go through the expectations for the discussion in part 2. You must discuss the primary, secondary, tertiary, and quaternary structures that are visible in your receptor figure. This isn't something you need to research in the literature. You're using what you've learned in class to describe what you see in your structure figure in terms of primary, secondary, tertiary, and quaternary structure. You must also discuss any ligands that are present in the structure, and I'll go through an example of this at the end. So you do need to choose a structure that has ligands present in it. For primary structure, you want to mention how many amino acids from the receptor are present in the structure. And is this the full-length protein, or is it maybe a specific domain of the protein? You want to label the N and C termini of the receptor in your structure, and is the first amino acid in the structure the first amino acid of the protein? And if not, why? And this goes back to whether or not this is the full-length version of the receptor protein. For your secondary structure discussion, it's not enough to vaguely mention that you see lots of alpha helices and beta strands or sheets. You want to be very specific and give an example of specific amino acids and numbers and interactions. So using what you've learned in class, what amino acid interactions do you see in these secondary structures? And if you want to, you could label some of the specific structures and interactions you talk about in your figure. Either way is fine, whatever helps you talk about them in the text. I've just underlined receptor here because some of you may have other proteins present in your structure, and that's fine. Gives you something to talk about for quaternary structure. But for primary, secondary, and tertiary structure, you're referring specifically to the receptor protein in the figure. And I'll give you an example of how you can look at some of these secondary structures. This is the mole viewer I showed you earlier in the presentation on the Protein Data Bank website. And you can watch that little 10-minute YouTube video I showed on the other slide, and it will show you how you can navigate around this mole viewer window. But what you can do is zoom in on a structure and click any part of that structure, and it will show you what amino acid is there. So you can see it's highlighted here and its name and number will show up down here. And then you can see what interactions its functional groups are part of. And in lecture, we talked a lot about the different kinds of interactions we see between amino acids in secondary structures. So you can go back to your lecture notes and review those. And then you can explore your receptor structure and give examples of these by giving, the specific amino acid numbers for a region of secondary structure, and then describe some of the specific interactions between amino acids in that structure. So be specific, give amino acid names and numbers, and the types of interactions you see between them. And you only need to give a couple examples. We really just want to see that you're really exploring the structure and thinking about what you've learned in class. And if you're using a different program to make the figure for your assignment, you can do this exact same exploration in those programs as well. You can zoom in and click on different parts of the structure as well. And remember that if there's more than one protein in your structure, make sure you're discussing the secondary structures of the receptor chains and not those other proteins. For tertiary structure, you're looking at whether the receptor chain folds into a specific domain or domains. And again, you want to look at which amino acids are mediating these interactions as different parts of the chain fold together. And you want to be specific and give an example. So you could try looking at the mole viewer again to see how different regions of the polypeptide chain are coming together. Or you might find some of this information in your structure paper as well. But you want to be specific and give an example of specific amino acid names and numbers and the interactions between side chains as different parts of your polypeptide receptor chain come together. For quaternary structure, you're looking at things like whether there is more than one chain coming together. So for instance, protein dimerization, or are there multiple proteins in the complex? And again, looking at what amino acids are mediating these interactions between different polypeptide chains, and be specific and provide an example with specific amino acid names and numbers and interactions between side chains. You do need to include a discussion of any ligands in the structure, so you should be choosing a structure that has some ligands, and you can find them by scrolling down to the structure summary page on the Protein Data Bank website until you get to the small molecules heading. And in your discussion, you're going to want to mention what these ligands are and what kinds of interactions they have with the amino acid side chains in your receptor protein. To look at ligand interactions, you're going to use the NGL viewer on the Protein Data Bank website. The default tab will be Structure View, which shows you the entire structure. Then if you switch over to Ligand View tab, there's a drop-down menu of all the ligands in the structure, and you can explore them all But if you have more than one protein in your structure, make sure that you select a ligand that's interacting with the receptor chain to discuss in your assignment. And you can look under the macromolecules section of the structure summary page to see which chains belong to the receptor, and then choose a ligand in that chain. So for instance, I was looking through at the different calcium ions in the structure and selected one found in the receptor chain because there were multiple proteins in my example structure. And then you can see the ionic interactions between this ion and the specific amino acids in the protein receptor chain. And here's an example of the other ligand in the structure, NAG, and again looking at the interactions between the NAG ligand and the amino acid side chains found in the receptor chain. And on the right, this legend will show what kind of interactions they are. So on the assignment, you need to discuss or briefly mention or describe, what the different ligands are, and then you need to discuss the different interactions between the receptor and the ligand that are occurring. And you don't need to include these figures in your draft assignment, but you can if you want to, if it helps you discuss the interactions you're seeing. If it helps, you can put them in either way. I'll also point out that these figures are giving a very zoomed out view and only showing the specific amino acids of the protein the ligand is interacting with. If you click on polymer display, just for your own interest, you can see how this ligand fits into the overall structure of your protein. But again, this is just for your own interest if you want to see how the whole thing kind of fits together. Part 3, you only need to discuss the methods that we've learned about in class. So if your paper talks about other techniques, you don't need to go over those. But this does mean that you need to choose a paper that includes the techniques that we've talked about in class. For part 4, if the information is not in your paper with your structure, then you're going to go into the literature and find a paper that talks about the interaction between the receptor and the growth factor. There's lots of papers on these. And then describe the amino acid interactions between the receptor and growth factor, giving specific examples of amino acid interactions. And then based on what you've learned in class about amino acid side chains, describe one mutation in the receptor that could interrupt these interactions. And this could be something you found in the literature, or you can just hypothesize about how changing an amino acid would affect certain interactions. And that's the last slide. So I'm sorry this video was a little bit longer than I meant it to be, but I hope that it helped clarify some of the expectations for each section and the different things that you need to include in each section.